Your chemistry tutor. We are in Vista's Learning, where we provide the quality education for all. Students, we are in chemistry 11th standard. We have already started our sessions, right? If you have lost any of the videos or if you are not getting, you can browse into our web application www.we-learning.in. Today, we are going ahead with the new chapter. Guess what? Which chapter is this? This is the carbon and hydrogen. You can see here we have this line-like structures, right? If we write like this in chemistry, we have a particular meaning for this. This is not just a plus, but we have one carbon atom with 4 bonds, and that bond is for 4 different carbon atoms, and each carbon atom at the end will be having 3 hydrogen atoms. So this is called as neopentane. Getting that? That means here each one line segment, if you write also, we have the meaning for it, and each end of the line segment will be having one carbon atom and satisfying the hydrogen. Its tetravalency will be satisfied with the hydrogen atoms. Similarly, you can see here one carbon atom with hydrogen. So when we have the catenation property of carbon, what happens? Carbon can combine with other carbon itself, and also hydrogen. So here in this chapter, we are studying about the carbon and hydrogen compounds, not any other. Instead, we have only these two, carbon and hydrogen. How many compounds are there? How we categorize these, or what is the classifications and what are their uses and preparations, we'll study in detail. What's the chapter name? That is hydrocarbons. This is our first lecturing class of hydrocarbons, and we'll get into the introduction part of this hydrocarbons. What do you mean by hydrocarbons, students? Hydro means hydrogen, carbon, carbon. Hydrogen and carbon combining together to form a compound will be called as a hydrocarbon. But here, not only one single compound is formed by hydrocarbon. As we know, law of proportionation, what happens here? We have different proportion in which carbon and hydrogen can combine, right? So here we have many chain-like structures which is been formed by carbon with hydrogen, which we categorize complete group as hydrocarbons. So the term hydrocarbon is self-explanatory, as we say here. Hydrocarbons means the presence of carbon and hydrogen only. Okay, so these hydrocarbons are very much important in our daily life. What's the classification? On what basis it has been classified? So they are classified into different types on basis of bonds. So depending on the types of carbon-carbon bonds, we have the classification made. They are classified mainly into 3 categories. First one is saturated. Saturated means it will be having single bond. No multiple bonds are formed. If you go with unsaturated bond, remember this is the bond between carbon and carbon. Always carbon and hydrogen will have only single bond. Don't get confused with carbon and hydrogen bonds. It is the bond between carbon and other carbon bond. If you have 2 carbon atoms which is having single bond, then that will be coming under saturated bond. If 2 carbons with double bond or triple bond, they come under unsaturated compounds. Got it? The third one is aromatic hydrocarbons. Here, the compounds which are having the benzene ring mainly will come under aromatic, and we also have non-benzene aromatic compounds that we'll study. Okay, what the hydrocarbons are classified into? They are classified into 3 groups based on carbon-carbon bonds. So carbon-carbon single bond will be called as saturated, carbon-carbon multiple bonds will be called as unsaturated, and we have the aromatic hydrocarbons which have the ring structure. Got it? Fine. Saturated hydrocarbons contain carbon-carbon and carbon-hydrogen single bonds. If different carbon atoms are joined together to form open chain of carbon atoms with single bond, then they can be termed as alkanes. So under this saturated, if you have single bonds, if you have single carbon bonds, a long chain, then whatever you can, how many numbers of carbon you want, you can just add on. These will be called as or termed as alkanes. Carbon and other atom which is satisfying the carbon tetravalency is hydrogen. So here, if we are not writing anything, it means hydrogen is present. Okay. So you can say that this is the group or chain of carbon which is having single bond. They should have the single bond, and that can be called as alkanes. If carbon atoms form closed chain, if we have a closed chain or a ring, they are called as cycloalkanes. Remember, even in the closed chain, you can have single bond or multiple bonds. So if they all are single bond, you can also take any of the structures. So what happens here? Each vertex will have one carbon atom. Okay, so that will be linked to hydrogen atoms respectively depending on their tetravalency, right? So if they have two carbon atoms which is adjacent and two bonds will be there, 1, 2, and the 2 will be for hydrogen. Got it? So if they are in cyclic form or closed form or ring, if they form a ring and they have a single bond, carbon-carbon single bond, they will be called as or termed as cycloalkanes. Remember students, it is A-N-E-S, alkanes. If it is ANES, that means it is carbon-carbon single bond always. Okay. Next, unsaturated hydrocarbons contain carbon-carbon multiple bonds. In multiple bonds, you will be having the double bond and the triple bond, or both can be present. For example, if I have a carbon with carbon-carbon double bond, then single bond, again carbon-carbon triple bond, and again single bond. So you can have only carbon-carbon double bond or only carbon-carbon triple bond or both. Then we call them as multiple bonds. Carbon-carbon multiple bond is present in the compound, and that compound can be categorized as unsaturated compound. Aromatic hydrocarbons are special type of cyclic compounds. They are special type of cyclic compounds where we'll study that hydrocarbons, aromatic hydrocarbons a bit later. Got it? So the first thing what we are concentrating here is alkanes, saturated hydrocarbons. Alkanes are saturated open chain hydrocarbons containing carbon-carbon single bond. Carbon-carbon single bond, and methane is the first member of this family. That means if I have one single carbon atom, even though if I don't have any carbon atom, this will be considered as alkane because it is linked with hydrogen, 4 hydrogen atom with single bond. Always carbon will form with the hydrogen a single bond, and here we have one carbon atom which is linked with 4 hydrogen atom forming methane. Meth means 1. So ane. Meth or methyl means 1 or CH3. Methyl means CH3 group, whereas meth means 1. So since we have one carbon atom, as I said, if we just know how many carbon atoms are there, we can easily find out the tetravalency of carbon. So hydrogen bonding to that carbon. If I have one carbon atom, then if there is no any other carbon atom linked to this carbon atom, then how many bonds the carbon will be having? According to the tetravalency, 4 bonds should be there for carbon atom. So how many hydrogen should be provided for this carbon atom? Obviously it will be 4. So what happens? We have 4 hydrogen atom for one single carbon atom. So this group with CH3 will be called as methyl group, where one hydrogen can be replaced by any other R group. Okay, that we'll study in detail. Now you have to remember, one carbon means meth. So since it is having only single bonds, so it will be called as methane, and this is the first member of alkane. Methane is a gas found in coal. When you do the destructive distillation of coal, we get this methane gas, and it is found in marshy areas also. This hydrocarbon with molecular formula C2H6 is called as ethane. That means ethane. Eth means 2. Meth, eth, prop, but, pent. Likewise, we have the Greek numericals which we are giving here. You can see here in the molecular formula C2H6. That means 2 carbon atoms will be having 1. So one carbon atom with other carbon atom, it is linked with a single bond. And how many bonds should each carbon atom contain? 4 bonds. So 1, 2, 3, 4. 1, 2, 3, 4. So we have hydrogen here. How many hydrogen will be for single carbon atom? 1, 2, 3, 1, 2, 3. Each carbon will have 3 carbon atoms because it will be bound with the other carbon with single bond. So totally 4 bonds for each carbon atoms, and 3 hydrogens are linked accordingly. Got it? So this will be called as ethane. Methane is CH4. Ethane is C2H6. If I take the next one, propane will be having 3 carbon atoms with single bond, and accordingly will be having the hydrogen bond. So 1 hydrogen, 2, 3, 4, 5, 6, 7 and 8. So we can see C3H8. So this is the compound. Here the outer or the terminal carbons will have 3 hydrogen, whereas the middle carbon will have 2 hydrogen linked to it. Why? Because the middle carbon will have single carbon bond, right? So totally 4 bonds for each. So now you can see CH4 is methane, C2H6 is ethane, whereas C3H8 is propane. Likewise, you can derive n number of hydrocarbons. The C2H6 has derived from methane by replacing one hydrogen atom by CH3 group. What is the CH3 group now? As I said to you, we have CH4 as a methane. Now, if I take 2 methyl group, CH3 is a methyl group, right? That means 1 carbon atom with 4 hydrogen bond. But what we do is that I have 2 methyl group. Okay. So what we do here is that this CH3, this CH3. Okay, here 1 hydrogen is there. We just remove this hydrogen and this carbon comes and attacks to this. So we get C2H6. 2 methyl group combine together to form this ethane. So we can just see this. If I take, this is, what is this? Methane. if I just take out one hydrogen and replace that with one methyl group. So what happens here? If I'm replacing it with one methyl group, either of the sides you can add, either here, here, or here. Okay, that will be giving you 2 carbon atoms, single carbon atoms with 6 hydrogen atoms satisfying its tetravalency. So that gives you ethane. Understood? So by replacing one hydrogen by methyl group, we can get this ethane. So replacing hydrogen atom by methyl group, the next molecule will be formed, that is C3H8, C4H10 and so on. So you can see here, this is the methane group where C and 4 hydrogen is there. This is the ethyl where C and 6 hydrogen is been provided. Whereas if I take this hydrogen and replace this with methyl group, then I will get the next member of alkane, that is 1, 2, 3, that is propane with how many hydrogen atoms? 8 hydrogen atoms. If I remove this hydrogen and again introduce one more methane group. So what happens? 1, 2, 3, 4. So C4, 3, 4, 5, 6, 7, 8, 9, 10. So H10. So this is the butane. Next, if I just remove this and add one more methyl group, CH3, then what happens? I'll get C5, H, 9 plus 3, it will be 12, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Got it? So it will be called as pentane. Are you getting this point, students? Good. These hydrocarbons are inert because normal conditions, as they do not react with the acid, base and other reagents. They are stable at normal conditions. Why? Because they are already saturated. They all have single bond and they are saturated, so they cannot easily react. Don't think that they never react, but they are not easily reacting. Okay, at the normal conditions, you have to remember this. They are inert under normal conditions. They are inert under normal conditions because they do not react with acid, base or other reagents, and hence they are early known as paraffins. Param means little, fins means affinity. Affinity means love towards. So if you have any affinity to react or to attract the other substances, then you are reactive. If you don't have any affinity to others, then you are stable. So they are, para means little or partially. So they are little they have very little or less affinity. Hence they are further, like before or earlier, called as paraffins. General formula of alkanes. What is this general formula of alkanes? Excuse me. So here we said we have a group of alkanes, methane till n number of alkanes. How to remember them and what is the common in them? As we said, each from methane till propane, what we see, what is common in them? Do you have any common? We have the only one single CH3 group which is added to it. So if you take in general, how is the formula given? General formula. If I take C, if it is 1, then hydrogen is 4, right? So we can take this in the form of this general formula. That means CnH2n, H2n plus 2. So if I try this for ethane, so Cn is C2 and H2n, 2 2s are 4 plus 2 is 6. So I get the formula for C2. If it is ethane, N will be 2 and C2H6. For propane, if I take C3 and H will be 3 2s are 6, 6 plus 2, 8. Got it? So whatever, if I take this general formula and if you ask me to write the formula for decane, as we know deca means 10. So for C10, what will be the chemical formula or molecular formula? For that, we can easily write H is equals to 2 into 10, right? 10 into 2 plus 2, that is 22. So then this will be the formula for decane. Got it? Octane, nano or dodecane, any of the things if they give also, if you know the number, then you can carbon number, you can easily find out the hydrogen atoms and hence we can derive molecular formula by using general formula of alkanes. Got it? Next. Methane has a tetrahedral structure in which carbon atom lies at the center and 4 hydrogen atoms. As we saw, we have this tetrahedral structure for methane. 4 hydrogen atoms and carbon at the center. Got it? All hydrogen bond angles will be around 109.5 degrees. In tetrahedral, it will be there, okay, 109.5 degrees. And in alkenes, tetrahedral are joined together in which carbon-carbon and carbon hydrogen bond lengths will be 154 picometer and 112 picometer respectively. And carbon-carbon and carbon-hydrogen sigma bonds are formed by head-on overlapping. If you have the carbon atom like this and the other carbon atom, the orbital, they can be easily found like this and hydrogen will be bonding like this. So that is the head-on. So you will be having sigma bonds. Carbon-carbon sigma bond, it is not the bond. Here sigma bond, here sigma bond here. So if I take this as carbon, here this is hydrogen, this is hydrogen. So what we get here one sigma bond, here one sigma bond, here other sigma bond. You will be having other orbitals also, but I am just showing you hydrogen, carbon, 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 sigma bonds. So carbon, carbon and carbon hydrogen sigma bonds are formed by head-on overlapping. This is the head-on overlapping. If we have the p orbitals, this, if they are connecting laterally, then we call it as pi bond. And here we have the sp3 hybrid orbitals for carbon. As I said in the previous sessions, sp3, 3 plus 1, 4. So as we know, carbon will have 4 tetravalency or valency will be 4 and it will be forming sp3 hybrid orbitals. So 4 hybrid orbitals we require for carbon. Always remember it might be having sp3 hybridization, but for alkanes always carbon will have sp3 hybridization. Why for alkanes it will be sp3 hybridization? Because it will be linked to 4 different hydrogen atoms or 4 different bonds. Either it might be hydrogen or carbon atoms. You can see here the tetrahedral structure of methane, where the bond between one carbon atom, one hydrogen with the carbon atom and the other hydrogen with the carbon atom will be 109.5 degrees. Next, coming back with the nomenclature. We need to know how to name this. As we said, methane, ethane, propane, we need to know how to name the higher alkanes. And is there any isomers? What do you mean by isomers? Here you have many types of isomers, students, but in alkanes, as if now for your syllabus, we are learning about structural isomers. What do you mean by structural isomers? In structural isomers, molecular formula will be same, but the bonding will be different. The carbons linking to the different carbon atoms, the chain will be different, or the structure will be different. So we call them as structural isomers. So first three alkanes, methane, ethane and propane, if you take, they have only one structure. They cannot have any isomers. What are they? The first three members. Methane, if I take CH4, I can just write only this structure. There is no other structure for this. And if I take the ethane, for this also, we have only two carbon atoms. There is no other structures. Even though you take the third one, all these three, methane, ethane and propane, we cannot change their bonds easily. So they have only one structure for one formula. Got it? But for higher alkenes, we have more number of structural isomers. They will not have only one structure, they will be having more than one. 4 carbon atoms, that is butane, C4H8, can be joined either in the continuous chain or with the branched chain. What do you mean by this continuous chain or branched chain? If you see here, I have 4 carbon atoms which is running one on the other. So this is a plain chain. Okay. So we call this as, what do we call this as? We call it as continuous chain. But if I remove one of this carbon atom, I'll remove one of this carbon atom, and instead of writing at the terminal point, I can attach that to this carbon atom. Getting the point? The same number of carbon atoms, same number of hydrogen atoms. There is no difference. But the structure is this. Before I was writing 4 carbon atoms with continuous chain or continuous one on the other, whereas now we have only 3 carbon atoms in the main chain or structure and one more will be branched. So it has been branched from here, right? If I consider this as a chain, then this will be branched. So we call that as branched chain. You can see here structure of 1 and 2 isomers. So we have 1, 2, 3, 4 carbon atoms with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 hydrogen atom with 4 carbon atom. Its molecular formula will be C4H10. We call it as butane, right? What about here? You can see here, right? 1, 2, 3. So 3 carbon atoms are in same straight line, but this one is branched or attached to second carbon atom. So what we can call this as, you will just check with the carbon atom. 4 carbon atom we have. What about hydrogen atom? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So both are having same molecular formula, but structure is different. If the structure is different, what about its name? Will it be same or different? You can see here, if it is a long chain, 4 carbon atoms by numbering either of the side. So 1, 2, 3, 4. 4 carbon atoms with a normal chain. There is no other branching. So we can call it as butane. Or since there is no other branching, we can also call that as in common naming. We call it as N-butane. We call this as but, because 4 carbon atoms with the same single chain. So with saturated bonds, we call it as butane. But here we have 4 carbon atom but within one single stretch, we have only 3 carbon atoms and the other is branched. So we cannot call this as butane. Instead, we call it as 1, 2, 3. So 3 carbon atom in same chain. So we can call it as prop. Prop for 3. So prop and all are single bond, we can call it as propane. But we have this methyl group, CH3 group attached to the second carbon atom. So we can call it as 2-methyl propane. Got it? We call it as 2-methyl propane. In common name, you can call it as isobutane. Since here for butane, we have only 2 structural isomers. One we call it as N-butane, the other we call it as isobutane. The nomenclature for IUPAC nomenclature here will be having butane and 2-methyl propane. This is not called as butane in IUPAC name. Okay. So next, structures of pentane. You can see the structures of pentane here. Pent means C5, right? C5 H12, because we have the general formula CN H2N plus 2. This is important, students. Even for your competitive exam, they may ask you what is the general formula for alkane. CN H2N plus 2. Okay, good. So we have C5H12 as a pentane molecular formula. Now we have these structures. How do we write these structures? So if I take all the carbon atoms in a single chain, all 5 carbons in the single chain, then I will get this pentane. As I said in butane, single chain butane. So here pentane. Whereas here in the second, we have 4 carbon atoms as a main chain. We call it as parent chain. So for parent chain, here it is 5, here it is 4. If you add either here or here, it will become pentane itself. But if you add that to we have 4 over here, right? If you add that to this carbon or this carbon, either here or here, then that will become the different or branched pentane. Okay, so here 4 carbon in the parent chain and 1 branched carbon. So that is what you have 4 chain here, 4 carbon atoms in a parent chain and 1 branch chain. So what do we call this as? As we know 1, 2, 3, 4. So 4, it will be called as butane because all single bond, and 1 methyl group which is attached to the second carbon atom. So 2-methyl butane. Got it? So here you can see 2-methyl butane. And the third one, if we go ahead with the third one here, we have 3 carbon atoms in the same chain and 2 branches. So here what happens? We have one, two, three. So 3 parent chain and the 2 branches in the second carbon atom. If you add 1 more carbon here, then that is wrong because it will become a butane. So only this structure you can do with propane or 3 carbon atoms as a parent chain and 2 branches. So this is what we can give 1, 2, 3 propane because all single bond. 3 carbon atoms with single bond, and we have 2 methyl group attached to the second carbon atom. So 2,2 dimethyl propane. 2,2 dimethyl propane. Hope you understand the students. Here we have, excuse me, here we have the structure with all the 5 carbon atoms as a parent chain. So we call it as N-pentane. We have here structures, right? What is this? If you take like this, so one segment 2 carbon atoms. Other segment, 3 carbon atoms. One more, 4. One more, 5. So it will be like this. If we write like this, we have 5 carbon atoms with same bond. You cannot write straight line. If you write straight line, it will be having only 2 endpoints. So it will represent the ethane. So to eradicate that, we want the vertices which represent each carbon atom. So we write like this. Okay. Whereas here, 4 carbon atoms. So 1, 1, 2, 3, 4. So to this, either this one or this one, both are same. So if I am writing here, I'll get one more carbon here. So 5 carbon, which we call it as a 2-methyl butane. Where here we can write 1 carbon atom. So we can write like this, 1, 2, 3. And one more is there, so we can write this like this, right? So instead of doing this, we can easily take like this, 1, 2, 3, 4, 5. 1, 2, 3, 4. If I take like this, then it will be the similar to this. So we are not taking here, instead here itself. So instead taking like this, we can take like a plus sign. Got it? So hope you understand this, students. These are the isomers of pentane. So butane, we have 2 isomers. Pentane, we have 3 isomers. As the number of carbon atoms changes or increases, the isomers may also increase. They are known as structural isomers. These are known as structural isomers. It is also clear that structures 1 and 3, what we have seen for butane and pentane, they are continuous chain. That means for butane, we have 4 carbon atoms, and for pentane, we have 5 carbon atoms. These are called as continuous chain, whereas the third, fourth, and fifth, which we saw, they are branched. How they were? Like this, and like this. So these 3 are branched chain structures. This is for butane, these 2 are for pentane. Such structural isomers which differ in chain of carbon atoms are called as chain isomers. Thus we can see the butane and pentane have 2 and 3 chain isomers. Based upon the number of carbon atoms attached to the carbon atom, these are termed as primary, secondary, and tertiary. What do you mean by primary, secondary, and tertiary? If you have a carbon, a single carbon, which is methane, then we call it as primary because there is only one carbon which is not linked to any other carbon. Then 0 carbon is linked to this carbon atom. We can call this as primary. Or if I erase one hydrogen and if I have one carbon atom here, then this will be having one single carbon attached to the other carbon. So we can call this as primary carbon atom. Got it? If I want secondary carbon atom, I can remove one more hydrogen and add carbon over here. So the first carbon is having only one carbon-carbon bond. So that is primary. But the second carbon will be having 2 carbon atoms which is attached to it. So now this will become the secondary carbon atom. If I want that to be tertiary, then 3 carbon atoms should be attached to this. We call this carbon atom. This is 1, this is 2. The second carbon atom which is linked to 3 different carbon atoms will be called as a tertiary carbon atom. If it is been linked to 4 carbon atoms, all the bonds are linked to 4 carbon atoms, we can call them as a quaternary carbon atom. Hope you are understanding this, students. Primary carbon atom can have only one carbon which is not linked to any of the other carbon atom, or it can link to only one carbon atom. Then we call them as a primary carbon atom. Or if it is linked to two carbon atoms, then the carbon atom which is linked to two different carbon atoms will be termed as secondary, and if it is linking to 3, we call it as tertiary carbon atom, and if it is linking to 4, we call it as quaternary carbon atom. Got it? In simple, we can write it as 1 degree, that is primary. This is secondary, tertiary, and 4 degree as a quaternary. So here, all these terminal carbon atoms are primary carbon atoms. Only this middle one will be called as a quaternary carbon atom, because only middle one is linked to 4 different carbon atoms, where others are linking to only one carbon atom. So they all terminal carbons are primary, whereas the middle one is a quaternary carbon atom. Carbon atom attached to no other carbon atom, as in methane, or to only one carbon atom, can be, as in ethane, can be termed as a primary carbon atom. And the terminal carbon atoms always be primary. Why? Because terminal means at the end. If they are linked to any one carbon atom, they will be having all the hydrogen atoms here. This is the end, the term, right? Terminal. Term means at the beginning or at the end. So terminal carbon atom will have only one carbon atom which is attached. They cannot have all. If they have here, then they are not called as terminal. Then this becomes terminal. Got it? So always terminal carbon atom will be primary carbon atom. Carbon atoms attached to 2 carbon atoms is known as secondary. 3 carbon atoms are known as the tertiary, whereas neo or quaternary will have 4 carbon atoms which is been attached to the single carbon atom. So remember, for primary, no carbon atom or else only one carbon atom. For secondary, 2 carbon atom. Tertiary, 3. Quaternary or neo, it will be 4 carbon atoms attached to the carbon atom. So this is the hexane. Hexa means 6. Ane for all single bonds. So hexane has got 5 isomers. How many? 5 isomers. Whereas heptane has 9. As many as 75 isomers can be possible for decane. For decane, that is carbon atom with 10 complete carbon atoms, they will be having 75 isomers. That means 75 structures can be formed by that chemical formula or molecular formula. So general formula of alkyl group, as we know, it will be CN H2N. Remember here, for alkyl group, if it is for alkane, then it will be CN H2N plus 2. This is for alkane group. For alkyl, methyl, propyl, butyl, then it will be one hydrogen less. So CN H2N plus 1. Okay. Here plus 2, that is for alkane. Here plus 1. Only one hydrogen, where one hydrogen is less. Why? Because if we take methane, we have 4 hydrogen atom. If I remove one, then we get this as methyl group, not methane. So that methyl group or alkyl group will be having one hydrogen less. We call it as CH3. So if I take C2H5, then it will be ethyl group. Got it? Next, nomenclature of substituted alkanes. Means if you remove one hydrogen and add the other group there, we call it as substituted alkane. Write structures of different isomeric alkyl groups corresponding to the molecular formula C5H11. So this is the pentyl group. So for that isomeric alkyl group, we need to write. And this is the homework, students. You can just go through that. So write IUPAC name of alcohol obtained by attaching OH group at different carbon of the chain. That means here we have the alkyl group. Answer for the second group. We can just try with the structural isomeric structures for pentyl group. Okay. So here if you take pentane, if it is been attaching OH group for the first carbon atom, we'll get pentane 1 all. All OL is the functional group which represent the functional group, that is alcoholic group. So pentane will be having 5 carbon atoms, right? So one hydrogen, if you remove this hydrogen and add OH group to this, then we'll get one pentane. We call it as one pentanol, or we can also call it as pentane 1 all. Whereas if I take the hydrogen here and remove the hydrogen and attach OH group to this instead of this, then we call it as pentane 2 all. Pentane 2 all. If I remove this and attach to the third one, we'll call it as pentane 3 all. Whereas for the 3-methyl butanol, this gives you the main structural isomer of pentane. So 3-methyl butane. In that 3-methyl butane, one hydrogen we are removing and adding OH group for the first carbon atom, we get this. So likewise, when we write the structural isomer and remove one hydrogen and add OH group, we get these number of isomers. So try it out doing the structural isomers for all these. And if you have any doubt, you can get back to us. So here are some of the examples where you can see the hexane, methyl hexane. We have 1, 2, 3, 4, 5, 6. 6 parent chain. So we get it as hexane. Okay. And we have the carbon atom which is attached to methyl group and ethyl group. So we have two substitution for this. So one methyl or two branches. One methyl and other ethyl. So what we need to do? First 4 ethyl, 2 methyl. Why we are taking 4 ethyl, 2 methyl? M and E, if you take according to the alphabetic order, E is first, right? Then M. So we write 4 ethyl, 2 methyl hexane. And we need to remember we are not numbering it from this carbon to this, because if you number from here, it will be 1, 2, 3. The third carbon will have the substitution, whereas here 1, 2, the second carbon will have substitution. Always the carbon atom should have less number where it is having the substitution. So we are numbering from this side. So 1 to 6, where the second carbon will be having methane and the fourth will have ethane. But while writing, we should not write 2 methyl 4 ethyl hexane. Instead, we have to write 4 methyl 2 4 ethyl 2 methyl hexane, because according to the alphabetic order, we have E coming first and then M. Got it? Similarly, we have other examples also. You can just go through that. So first of all, the longest chain of carbon atoms corresponding to the parent alkane is been written. While writing the formula, structural formula, what we need to write? If we give you any number, you have to write the first parent alkane chain, and then after numbering it, the substituent are attached to the correct carbon atom. We first have to number and then attach the substituents to that carbon atom, and finally valence of each carbon atom is satisfied by adding the correct number of hydrogen atoms. For example, if I tell you to write 3 methyl hexane. So how to write this? Which gives you the parent chain? Hex. Hex means 6. Hexa. So we have 6 carbon atoms. So numbering 1, 2, 3, 4, 5, 6. Either you can number from here or there. Okay. 3-methyl means at third carbon atom we have methyl group present. So this will give you 3-methyl hexane. Now I didn't satisfy the hydrogen atom to the carbon atoms, right? So I have to write the hydrogen atoms. Seeing that each carbon atom, this carbon atom have one carbon bond, so 3 hydrogen. Here 2, here. So 2 hydrogen atom. Here 3 carbon atoms, and so 1 hydrogen. Here 2 hydrogen. Here also 2 hydrogen. Wherefore this terminal one, we have 3 hydrogen attached to the carbon atom. Can you find out, students, which is primary, secondary and tertiary here? If you see the terminal carbon atoms, as we said, that will be having only one carbon atom attached to it. So that will be primary. So these two are primary carbon atoms. When you see the second and the fifth, even the fourth one, second, fifth and the fourth one, these three are secondary carbon atoms. Whereas the third one, if you see, this is attached to 1, 2 and 3. So it will be exhibiting tertiary carbon atom. So we can call this as tertiary carbon atom. Whereas this is also a terminal one. So or branched one, we can call this as also primary carbon atom. You should know how to know the primary, secondary, tertiary and quaternary carbon atom. Draw the chain of 5 carbon atoms as they have been showing here. Give the number of carbon atoms to each and then attach ethyl group to carbon atom at 3 and 2 methyl groups at carbon 2. So here we have 5 carbon atom. At second we have methyl and we have 2 methyl group at second carbon atom and 1 ethyl group at third carbon atom. So if this is the structure, what might be the name, students? So satisfy the hydrogen atom as we find here, we get this structure. So 1, 2, 3, 4, 5 pentane with 2, 2 diethyl, 3 ethyl. So how can we write this? As I said, either it is first, methyl is first or second. We need to go with the what? We need to go with the alphabetic order. So what happens here? 1, 2, 3, 4, 5. Pentane. Right. So here for the pentane we have 2, 2, 2 dimethyl and we have 3 ethyl. So we should see M and E. So E is the first in alphabetic order. So 3 ethyl and we have 2, 2 dimethyl pentane. Okay. So we have 3 ethyl, 2, 2 dimethyl pentane as a name for this structure. Got it? Good. So by this we finishes our first session of hydrocarbon strains. Do you have any doubts? You can get back to us. Just search so many numbers of hydrocarbons, try to write their structural formulas, isomers, and by coming with the next class or session, we'll have a trick how to find out how many isomers are there in the given molecular formula. Got it? Hope you enjoyed this class. If you have any doubts, you can get back to us. Thanks for watching Vista's Learning.